Hello and welcome guys to my YouTube channel. Today we're going to be covering percentage increase and decrease, or otherwise known as percentage change. Most of the questions that you will face about percentages will revolve around this topic. Now you should feel more confident dealing with basic percentages, and we're going to dive into more complicated percentage applications. Now, there is a rule that we use for all percentage change applications. I will write the rule down. It's new equal old into 1 plus or minus r over 100. Okay? Now, the r over 100, this entire thing is the percentage. Okay? Now, about the plus and the minus, it depends on whether you're dealing with increase or decrease. So you're going to use the plus when you have percentage increase, and you will use the minus when you have percentage decrease. Okay? Now, how would you know if it's percentage increase and decrease? The question might either state it directly or imply it. We will see now. Let's take this example. With percentage questions, it's really important to read the word problem thoroughly, okay? And translate each of the variables you are given into your equation. A store is having a 30% off sale. Already by now, you should know this is percentage decrease because it's a sale, okay? So decrease. So I already know that I will use the minus, okay? And the store is having a 30% off. This is R. R is equal to 30. Now, a shirt originally costs $20. What's the new selling price of the shirt? So he's asking for the new price. The original price, which is basically the old price, is $20. So now we know that the old price is equal to $20. R is equal to 30. And the new price is unknown. It's what I want to find. Okay? So we're going to now write the rule. So the rule is right here, new equal old. So we're just gonna plug in the variables. N is equal to 20 multiplied by 1. And I'm gonna choose minus because as we agreed, this is a percentage decrease question. 30 over 100. And this is very direct, honestly. You just plug the whole thing on your calculator and you will get the answer. I will plug it now. It's equal to 14. So the new price of the shirt is $14. Okay? Let me just put it. I hope this was well understood. In all the cases, you always have 3 variables. You will know 2 of them, and the third one is the one you want to find. In this case, we knew the old and we knew the percentage, and all we need to do to find was the new one. Now, and by the way, don't make the mistake of plugging R as 30%. You don't do it with the percent. The percentage doesn't go into the rule because it's already divided by 100. So this entire thing is already 30% as it is, okay? So always take the R as just a number without the percentage sign. Let's move on to example 2. John invested $1,000 into the stock market. 2 years later, his money increased by 30%, okay? So we know his money increased. How much money does John have now? Now again, so you can by now identify this is a percentage increase question, so we're going to use the plus from the rule, okay? I will write the rule down firstly. N equal, which is new, old, into 1 plus r over 100. It's inconvenient to write a new and old every time, so just get used to writing n and o. Now, he invested $1,000, okay? And his money increased by 30%. How much money does John have now? So we want the new amount of money, and this right here, the $1,000, this is the old amount of money. So now we're going to plug in. So we know the old is equal to $1,000. R is 30%. And the new is unknown. This is what we want to find. So now we're going to say new is equal to 1,000 multiplied by 1 plus 30 over 100. Okay? Now again, you simply plug the whole thing into your calculator and you'll get the answer as $1,300. This is how much money Joan has now. I hope this was well understood. Moving on to example 3. Okay, so Ali's weight decreases from 120 kilograms to 90.9 kilograms. Calculate the percentage decrease in Ali's weight. So the question stated that this is a percentage decrease. So we already know that we're going to use the minus and give your answer correct to 3 significant figures. Okay, let's solve this. So we're going to use, again, new is equal to old multiplied by 1 minus r over 100. Okay. Now, if we take a look at the question, we know that the new, we got the old, we have r. Okay. Now let's focus here. His weight decreases from 120 to 90.9. So which do you think is the old and which is the new? The old is the 120 and the new weight is 90.9. Because he decreased from 120 to 90.9 over time. R is unknown. R is actually what we want to find because he's asking us to calculate the percentage decrease. So we want to find R. Okay. Now let's plug in our variables to the equation. So 90.9 is equal to 120 multiplied by 1 minus R over 100. Okay. Now, there is multiple ways to do this. You can, for example, expand the 120 into the bracket. You will still get the right answer, but it's a little bit of a longer method. The easiest thing to do right now is to simply divide by 120. Okay? Over 120 over 120. Because the 120 is multiplied by the entire bracket right here. Okay? So I will divide by 120 and cancel it out. Now, on the left, you simply plug on your calculator 90.9 divided by 120. 0.7575. Or write it as a fraction, but this needs to stay accurate. Now, since we've divided by 120, there is no longer anything multiplied by this bracket, so there's no need for the bracket. So we just write down 1 minus r over 100. Okay. Now, again, there's also multiple ways to do this. For example, let's subtract 1. Minus 1. Minus 1. And we will get, on the left-hand side, negative 0.2425. And on the right, we will get negative r over 100. Be careful. Don't lose the negative over here. This sticks with the r. Now, finally, we're just going to multiply everything out by 100 to cancel out the denominator. And multiplying it by 100 will give you 24.25 is equal to negative r. I forgot the negative here. Now, in order to get rid of the 100, we will, the negative, we will multiply by negative 1. So finally, we get r is equal to 24.25. Okay? So now, so what's the percentage decrease? Rounded to 3 significant figures. Let's see. This is the first significant, this is the second significant, and this is the third. The 2 goes over here. It gets rounded up. It becomes 3. So 24.3%. Don't forget the percentage sign, because this is a percentage decrease. I hope this example was understood. Okay, example 4. In 2006, Julia's height was 130 centimeters. In 2010, Julia's height became 160. When you're dealing with years like this, you can easily tell what's old and what's new. The older one is 130 in 2006, and the newer one is 160 in 2010. Okay? Calculate the percentage change in Julia's height. Okay, so as we can see, we know that the new height is 160. We know that the old height is 130. And we know that r is unknown. This is what we want to find because he wants the percentage change. Now let's write the rule. New equal to old multiplied by 1, r over 100. The question is this a plus or a minus in between them? So the question doesn't mention it directly. It just asks for a percentage change. Okay? So now it's your job to figure out if it's an increase or a decrease. So if you take a look here, her height was 130 and then it became 160. So this was obviously an increase. And so now I know that this over here should be a plus because percentage increase. Okay. Now let's plug in our variables. So we have 160 is equal to 130 multiplied by 1 plus r over 100. We're going to start off again. This is the same concept as the last question, really. So we will divide by 130. Okay. Now, if you plug this left side on your calculator, you will get a really long decimal. So I would recommend to just keep it as a fraction, as 16 over 30. Okay. Is equal to, of course, this 130 cancels out. And again, there is no need for the brackets anymore. So we will just have 1 plus r over 100. Now, the next step is to get rid of this one. So minus 1 over here. Again, plug this on calculator and write down the accurate answer, preferably in a fraction. So it will be 3 over 13 equal to r over 100. Finally, I multiply by 100 and we get the r. Now you can just again plug this on the calculator and multiply it by 100. You will get r is equal to 23.0769, so on. Now, writing down the final answer, the percentage change is equal to, we're going to round it to 3 significant figures. Generally, we always round to 3 significant figures unless stated otherwise. So this is the first significant figure. This is the second, and this is the third. Of course, a 0 will get rounded up because this is a 7 over here. So this becomes 23.1 Okay, this is the answer. Okay, now we're going to move to exercises. You should pause the video, and for each of those exercises, attempt to solve each of them. Okay, let's start with the first one. Last year, there was 20 students in a class. This year, there are 30% more students. How many students are in the class this year? Okay. So, reading the context of the question, we can tell this is a percentage increase question. Okay. Because there are 30% more. This is what gives you the clue that this is increase. Okay. Now let's write the rule. New equal old multiplied by 1 plus r over 100. And now we need to identify what's the new, what's the old, what's the r. Which of them do I need to find and what do I know? Now, 20 students in the class. This was last year. Now we're dealing with this year. So the 20 is obviously the old. Okay? So 20 is the old. Now this year, there are 30% more students. So what's R? It's 30. And now, how many students are in the class this year? So you need how many students? This is obviously the new. This is what we want to find. The new number of students in the class this year. So we're going to say new equal 20 multiplied by 1 plus 30 over 100. Okay? And again, you just plug the whole thing on your calculator and you will get 26. So the number of students in the class this year is 26 students. Now moving on to exercise 2. Again, you should pause the video, try to solve it on your own. Over the past 10 years, the population of a town has increased by 25%. Okay? So from this first sentence, we can already tell we're dealing with percentage increase. So the rule will be with the plus beside the R. And this is the increase. This is obviously R. The population of the town 10 years ago was 18,000. Okay, this was 10 years ago. What is the population of the town now? Okay, so again, we're going to write down new equal old multiplied by 1 plus R over 100. And okay, so let's see. N, O, and R. Now he's asking what is the population of the town now? So this is obviously the new. It's unknown and we want to find it. 10 years ago, the population was 18,000. This was the old population. So we're going to plug in 18,000 over here. And R is 25. So N is equal to 18,000 multiplied by 25. Oh, I'm sorry. Multiplied by 1 plus 25 over 100. This is also straightforward. You just plug the whole equation on your calculator. You should get nu is equal to 22,500. Okay, so this is the new population of the town. Moving on to exercise 3. Again, pause the video, try to solve it on your own. Gabriel's salary is $24,500. Next year, he is due to get a 9% increase. What will his new salary be? Okay. So his current salary is 24,500. This is the old one. And he is going to get a 9% increase. So this is R. And since this is an increase, so the rule will have a plus beside the R. And what will his new salary be? This is the unknown. So we don't need to write the rule every time. We're just going to jump into the substitution. So 24,500 multiplied by 1 plus 9 over 100. Okay. Now again, just plug the whole thing on your calculator and you should get new is equal to 26,705. This is his new salary. Okay. Now, let's take a look at this question. Again, pause the video, try to solve it on your own. A laptop was originally priced at $1,200, but now it's on sale for $960. Okay. What is the percentage change in the price? Okay. So from the context of the question, you can tell that the original price of the laptop is $1,200, but now there is a sale, and in this sale, you have the new price of the laptop as $960, okay? And we want to know the percentage change in the price. So R is unknown, but we do know the new price and the old price. The old price is the original one, the previous one, which is 1,200. The new price is $960. Now we're going to use the rule. So new is equal to old multiplied by 1. We're going to put R over 100 here. And now the question is, do we put a plus or a minus? So the question didn't directly state that it's a percentage decrease. It just said percentage change. But you can tell that it's, well, the price was 1,200 and became 960. So this was a decrease. Okay. So we're going to use minus. So again, let me erase this one. Okay. So again, so when the question doesn't directly state if it's an increase or a decrease, you need to look at the context of the question, understand the scenario, okay? And through the scenario, you can know if it's a decrease or an increase. So we're going to put minus right here. Now let's just go and plug in. We're going to substitute our variables. So we have the new as 960 equal to 1,200 multiplied by 1 minus R over 100. Okay. So we've dealt with this kind of equations before. Like I said, the easiest thing is to just get rid of the 1,200 that's multiplied by the entire bracket. So we're just going to divide by 1,200 on both sides. On the right side, it's going to cancel out. On the left side, I'm just going to keep it accurate as 96 over 120. I simply just crossed out the zeros. You can plug this on your calculator, okay? It might give you a more simplified form. If you plug it in, it will give you 0.8. So you know what? Let's just use 0.8. But if it doesn't give you an accurate decimal, then keep it as a fraction, okay? Is equal to 1 minus R over 100. As we've said before, those brackets, we don't need them anymore because the thing that's getting multiplied by the bracket just got cancelled. Okay, now normally we would subtract 1 and then multiply by 100 and then negative. This time, let's try something different. We're going to add R over 100. So it cancels out from the right side and it comes to the left side. Equal to 1. And we're going to now subtract 0.8. This will give you R over 100 is equal to 0.2. And finally, we multiply both sides by 100 and get that R is equal to 20. Okay, so the percentage change is equal to 20%. Okay. Okay. That's it for the exercises. Moving on. So far, we've dealt with cases where, okay, so new, old, and the percentage. New, old, and the percentage. New, old, and the percentage. So for the most part, we've dealt with cases where we knew the new price, we also knew the old price, but did not know the percentage. Or we knew the old price and the new one, I mean the percentage, but we did not know the new price. Now we're going to deal with cases where we don't know the old price, but we know the new one and we know the percentage change. Okay, let's take a look at this question. This is an example, so you don't need to try to solve it. The normal price of a smartphone is reduced by 25% in a sale. Okay? A sale is always a percentage decrease. Always. Okay? So negative. 25%, so this is obviously the R. Let me just fix it. Alright, this is the R. Now, the sale price of the smartphone is $600. Okay, so you need to understand this $600, this is a sale price. Okay, so this is after the sale, after the reduction in price. Okay, work out the normal price of the smartphone. Okay, so through the context of the question, we know R, it's 25, and we need to identify which is the new and the old. I'm going to write down the rule first. New is equal to old 1 minus R over 100. Okay, now, so what do you think is the new? What do you think is the old price? Try to pause the video and think about it. Now, here's the thing. You had a phone, okay, that had a certain price. And then a sale happened. And then you have this new price, okay? So when he says the sale price is $600, this is after the sale. So this is the new price. This is the new price. The old one was before the sale. Okay? I hope you're clear on this because a lot of students sometimes get confused and think that the 600 is the old price. No, it's the new one. It's the one after the sale. Okay? So we have two timelines here. After sale, before sale. And the money, the amount of money that's right here, this is after the sale because this is the sale price. Okay? So it's after the sale. So this is obviously the new, and this before the sale, this is the old. So the new price is 600 and the old one is unknown. So now we're gonna plug in our variables. So 600 is equal to old multiplied by 1 minus 25 over 100. Okay, now how do we solve this algebraic equation? Again, the easiest thing to do is always the first step in solving any algebraic equation is to collect like terms, okay? Any variables that are alike and any constants must be collected together. So expanding the old price in here is not a good idea. It will only make things more complicated. Your priority is to collect all like terms. Okay? So as you can see here, there's two constants that are being subtracted. So this is obviously what you start with. So you plug on your calculator 1 minus 25 over 100. This will give you old multiplied by 0.75. Okay. Now, How would you calculate this? Well, you have 0.75. It's multiplied by a variable is equal to 600. So in order to make this variable the subject, you are simply going to divide by 0.75 because this is a multiplication right here. And divide, obviously, both sides. On the right-hand side, this will get cancelled. And you're going to get the original price to be 600 divided by 0.75. Plug it on your calculator, you get 800. So this is the old or the normal price of the smartphone. After the sale, so before the sale was 800. After the sale, it became 600. This is the old, this is the new, and the R is 25. I hope this was clear. Let's take a look at another example. Okay, a handbag is on sale with 35% discount. The sale price of the handbag is $975. After the sale, the handbag's price increased by 20%. So increased by 20%, we can already tell this is a percentage increase question. Now, what was the price of the handbag before the 35% discount? And what will be the price after the 20% increase to the sale price? Okay, so this is a complicated question. We need to do this carefully and slowly. Let's firstly understand the scenario, okay? So we have a handbag that's on sale with 35% discount. The sale price is $975. So this is a sale price, okay? So you have before the sale and after the sale. And this is obviously the old, and here it will be the new, okay? Now, the sale price of the handbag is $975. So this is the cost right here. After the sale, it's costing $975. This was due to a 35% discount, okay? So now a discount or a sale, like we said, is always a negative, okay? So it's a minus beside the R. So it was a 35% discount. And we have an old price for this bag that we don't know, okay? Now, if you continue the question here, it says that after the sale, the handbag's price is increased by 20%. So as we said, this was before the sale, this is after the sale, okay? So after the sale, we increased the price of the handbag by 20%. So now let's take a look at the question. I hope you understood the scenario that we're dealing with. I will repeat it one more time. So we have before sale and after the sale, okay? Before the sale, we don't know what was the price of the bag. This is why we said old price. But we know that the sale price of the handbag is $975. So this is the $975 after the sale, okay? Or the discount, okay? How much was the discount? It was 35% discount, okay? And then he said that after the sale, so now we're in this area, the handbag's price is increased by 20%. So we increased by 20% the price of the bag. Okay. So let's deal with part A firstly. So he's asking us what was the price of the handbag before the 35% discount. So as you can see right here, we want to know the old price before we had a 35% discount. So this was a discount scenario. So right here, we're going to use the percentage decrease formula, which is new is equal to old multiplied by 1 minus R over 100. Okay. the new price, which was after the sale, is 975. The old price is unknown, and R is equal to 35. Now let's plug this in. So 975 is equal to old multiplied by 1 minus 35 over 100. Like I said, the easiest thing to do is to simply plug in 1 minus 35 over 100, okay? Plug it in the calculator, it will give you the old multiplied by, this will give you 0.65 is equal to 975, okay? So now we're simply gonna divide by 0.65, divide both sides, and we get the old price. So plug in your calculator, 975 divided by 0.65, $1,500, okay? I hope this was understood. This is for part A, okay? Let's go here, we're running out of space, kind of. Now we can just erase this, okay? And now we know that before the sale, the price of the bag was 1,500, okay? I did a 35% discount, which made the bag have a price of 975. Okay, now, what does part B say? What will be the price after the 20% increase to the sale price? Okay, if you go back to the question here, it says after the sale. So after the sale, firstly, at the sale, how much was the price of the bag? It was 975, okay? So during the sale, it was 975, okay? Now, after the sale, the handbag's price is increased by 20%. So after sale, we increased the price by 20%, okay? So now B is asking, what will be the price, okay, after the 20% increase? So he wants the new, basically. We know the old is 975. The new price, we don't know it, and R is equal to 20. So we will plug this in. So we have new is equal to 900. Oh, sorry. Okay, 975 multiplied by 1 plus 20 over 100. Okay, and like I said, you can just plug the entire thing on your calculator. This is straightforward, and you will get that the new price is equal to 1,170. Okay, this is the new price after the sale. This question is not easy. It's more on the advanced side. I hope it's clear. I will draw a diagram and explain one more time the scenario that happened here. So we have 3 timelines for this question. The timeline starts with firstly before sale, and then during sale, and then finally after the sale was over. Okay? Now, when you start the question, the handbag was on sale with a 35% discount, and the sale price was 975. So the sale price here was $975. This was during the sale. Okay? This was a 35% discount. So this is why this is negative 35%. This is why we use the negative in my rule right here. Okay? And we didn't know the old price. So right now, this is the old and this is the new. Okay? Now, then we figured out the old price. We figured that it was $1,500. Okay? Now, then the question continued and said after the sale, the handbag's price increased by 20%. So after the sale, so now we're done with the sale. Moving on, we have an increase of 20%. So this is why we use the positive in our rule over here. Okay? And now he was asking what was the what will be the price eventually after the sale. Okay? So this is a separate scenario. In this scenario on the right, the new is right here and the old is this. The old is 975 and the new one is after the 20% increase. However, before sale and during sale, the older price was the 1,500 and the newer price was the 975. Hopefully this was clear to you. Okay. So you should pause the video for each of those exercises and try to solve them. Let's take a look at each of them. A jacket is on sale with a 15% discount. Okay. So the jacket is on sale. You can already tell this is negative. This will be minus percent R. And 15% discount, this is R equal 15. The sale price of the jacket is $85. This is the sale price. Okay. What was the price of the jacket before the discount? So new is equal to old multiplied by 1 minus R over 100. And like the question states, really, there was a before sale period and the sale period. And the sale price is $85. Okay. And before the sale, we don't know the price. This is what we want to know. So this is the new. Okay. And there was a 15% discount on the original price. Okay. So new is $85. The original price is unknown. And the discount is 15%. Okay. That's R. Now we're just going to plug in the numbers. So 85 is equal to original multiplied by 1 minus 15 over 100. Like I said, the easiest thing to do is to evaluate what's inside the bracket. We collect the constants. 1 minus 15 over 100 will give you 0.85 is equal to 85. And now we will divide by 0.85 and divide by 0.85. This cancels out. 85 divided by 0.85 is 100. Okay. So the jacket costed $100 before the discount. Okay. Moving on to the next question. A car dealership is offering a special promotion where the price of a car is first reduced by 30%. Okay. So we're going to reduce it by 30% and then an additional discount of $2,000 applied. Okay. After all the discounts, the final price of the car is $28,000. Find the original price of the car. Okay. So again, we're going to draw a small diagram here to understand the scenario. It really helps. Okay. So you had a car that had a certain price. And this was the original. We don't know it. This is what we want to find. Now, the way that the offer works is that the car's price is reduced by 30% reduction. Okay? And after that, you have a new price. Now, This new price, the promotion also subtracts $2,000 from it, and then you will have the final price. Okay? So, if the final price of the car is $28,000, can we find the original? Yes, you just need to trace back, okay? So, if I'm looking right here, I'm like, okay, let's trace back. How do I trace back? Well, I know that the final price is $28,000. Okay? So, this is a 3-step process. Let's go back to the second step. So, how did we get the 28,000? It was we had the previous price and we subtracted 2,000 from it. So, how will I have the previous price of the 28,000? I will add 2,000. You will get 30,000. Okay? So this was the first step. It was to find the car's price before the $2,000 reduction. Okay. Now I want to find the original price. Again, you ask yourself, how did I get to the 30,000? Well, I had an original price right here, and I reduced it by 30%. So this was a percentage decrease. Okay. So now we're dealing with a percentage decrease equation. So the new is equal to old multiplied by 1 minus r over 100. The new price is 30,000. The old price is what I don't know. It's the original one. And finally, the r is 30. Okay. So we're going to plug in. So this is 30,000 is equal to old multiplied by 1 minus 30 over 100. We will evaluate what's inside the bracket. 0.7. And then we're going to divide both sides by 0.7. So plug on your calculator, 30,000 divided by 0.7. So, of course, this cancels out. So the original price is 42,857.14 and so on. Now, the question did not specify a degree of accuracy, so we will just do 3 significant figures. So this is the first significant, second significant, and third significant. So the 8, there's a 5 beside it, so it will be rounded up to 9. And these numbers over here will be turned to 0. So the final answer is $42,900. This was the original price of the car. This is it for percentage increase and decrease. I hope it was clear. Thank you for watching.